year is 1889. A revolution took place in the world of beekeeping. Not a revolution of force, but a revolution of knowledge. One man understood the biology of the honeybee colony so precisely that he changed queen rearing forever. His name was G.M. Doolittle. Up to that point, beekeepers had mostly waited for nature to make the decision. Doolittle was the first to show that humans could control that process, not against nature, but together with it, with almost surgical precision. Today, in the Eterna system, we return to the roots of modern queen-rearing science. This is not just beekeeping. This is biology. This is the engineering of life. Welcome. In our previous lesson, we saw how honeybees naturally choose the larva that will become their next queen. Today, we take one step further. Today, humans take control of that choice, but without changing nature's rules. We simply understand them and use them to our advantage. That is the essence of the Doolittle Method. By the end of the 19th century, producing high-quality queen bees was a major challenge. Beekeepers relied mostly on the swarming instinct or on random emergency queen cells. The results were inconsistent. Some queens were exceptional. Others failed to meet expectations. No one could guarantee their quality. Doolittle asked one simple question: what truly determines the quality of a future queen? He did not find the answer in the queen herself, nor did he find it in the hive. He found it in the larva. That discovery changed everything. A honey bee larva is not predetermined to become either a worker or a queen. Its destiny depends on nutrition, from the moment it begins receiving large amounts of royal jelly, and on how young it is when that process begins. That was the key. Not just any larva, but a larva between 12 and 24 hours old, approximately half a day to 1 day after hatching. A larva that is almost invisible to the naked eye. That is why serious queen breeders today select exactly that stage of development. Not because it is tradition, but because that is how biology works. The younger the larva, the greater the chance that it will develop fully into a reproductive individual. That means more ovarioles, better developed glands, greater vitality, and a longer productive life. Ideal larval age, 12 to 24 hours, maximum royal jelly intake, highest developmental potential. But how do you identify exactly that larva? This is where true skill begins. An experienced beekeeper does not look for the largest larva. They look for the smallest one, almost transparent. A larva that barely floats in a thin layer of royal jelly. That is the moment when its biological potential has not yet been limited. That is exactly where the Doolittle Method begins. The next step requires a steady hand, and even more importantly, a complete understanding of biology. The larva is carefully transferred from a worker cell into an artificial queen cell cup, without applying pressure, without turning it over, without allowing it to dry out. Every movement lasts only a few seconds, yet those few seconds determine success. Grafting is not a mechanical task. It is working with a living organism. The larva is extremely delicate. A single drop of water, one incorrect angle, one movement with too much pressure. Any of these is enough to interrupt its development. That is why professional queen breeders work slowly, calmly, with maximum concentration. Key requirements: checkmark 12 to 24-hour-old larva. Checkmark continuous humidity. Checkmark minimal time outside the hive. Checkmark stable temperature. Temperature plays an enormous role. Honeybees maintain the brood nest at approximately 35 degrees Celsius, 95 degrees Fahrenheit. That is not a coincidence. It is the temperature at which development proceeds almost perfectly. Any prolonged deviation increases the risk of developmental problems. That is why experienced queen breeders never leave grafted larvae outside the hive for long. Every minute matters. But even perfect grafting is not enough. Now we come to the question that separates average results from outstanding ones. What happens after the grafted larva is returned to the bees? Why are some larvae accepted almost immediately, while others are completely rejected? The answer is not found in the larva. It is found in the strength of the colony. And that is where the next chapter of the Doolittle Method begins. A larva never becomes a queen on its own. The colony makes that decision. When we introduce a grafted larva into the queen-rearing colony, the bees begin evaluating it within just a few minutes. Is the larva young enough? Is it healthy? Does the colony have enough young nurse bees? Is there enough royal jelly available? If the answer to all of these questions is yes, the construction of the queen cell begins. If not, the larva will be rejected. That is why success never depends solely on grafting. It depends on the quality of the entire honeybee colony. This brings us to one of the most important principles of the Eterna system. We do not produce queens, we produce the conditions. When the conditions are properly established, the bees do most of the work themselves. That is the difference between working against nature and working together with nature. The stronger the queen-rearing colony, the more young nurse bees it contains, the more pollen, honey, and nectar it has available. The higher the quality of the queens will be. Biology makes no compromises. Eterna system, principle. Checkmark strong bees, checkmark young nurse bees, checkmark abundant food supply, checkmark stable microclimatic conditions, checkmark continuous flow of royal jelly. Doolittle understood another important fact. A queen is not the product of a single moment. Her value is built throughout her entire development, from the very first drop of royal jelly until she emerges from the queen cell. Every hour of development leaves its mark. That is why professional queen breeders pay attention to every detail. From selecting the breeder colony, through the grafting process, to the final maturation of the queen cells. A single mistake can reduce the potential of superior genetics. Today, we have access to modern tools. There are better grafting tools, more precise artificial queen cell cups, modern incubators, digital thermometers, digital hygrometers. But not a single tool has changed the fundamental principle. Biology has remained the same, exactly as it was in 1889. Technology can help people, but it cannot replace nature. That is precisely why the Eterna system does not view the Doolittle Method as a historical curiosity, but as a foundation. It is on that foundation that we build modern beekeeping today. We use modern materials, modern instruments, more precise measurements. But we never change the biological principles that Doolittle understood more than a century ago. That is the difference between a method and a philosophy of work. A method can be improved. Biology cannot. 1889 to today. Biology check precision, check control, check respect for nature, check. The most common mistakes are not complicated. Choosing larvae that are too old, a weak queen-rearing colony, a lack of pollen, taking too long to graft, allowing the larvae to dry out, poor organization of the work. Most failures are not caused by the method itself. They result from deviating from the fundamental principles of biology. The Doolittle Method does not forgive improvisation. It rewards discipline. when we combine superior genetics, a properly selected larva, a strong queen-rearing colony, and precise organization. The result is not just a new queen. The result is a stronger honeybee colony, greater development potential, more stable overwintering, a reduced swarming instinct, and in the long term, a healthier apiary. That is why the Doolittle Method remains the gold standard of professional queen rearing around the world to this day. The years pass, technology changes, equipment becomes more advanced, but one thing remains the same: nature. Doolittle did not defeat nature. He understood it, and that is exactly why his legacy has endured for more than a century. At the Eterna system, we believe that true knowledge is not about changing nature. It is about understanding its principles. Because when we understand biology, precision becomes a habit, and success becomes predictable. If this analysis helped you better understand the Doolittle Method, please support the series by liking this video and subscribing to the channel. By doing so, you help us continue building one of the most comprehensive libraries of beekeeping knowledge. But today, we would also like to do something more. The Eterna system is not just a collection of videos. It is a community of people building knowledge together. One member of our community, at Burger Tiedson 76, suggested that we create a detailed analysis of the Miller Queen rearing method. His suggestion has been selected as our next premium lesson. In the next episode, we will explore how the classic Miller method works without grafting larvae. We will explain the biological triggers that initiate queen cell construction. We will analyze the correct shaping of the comb. We will discuss honeybee colony management, and we will demonstrate how this historic method can be enhanced through the principles of the Eterna system without altering its original biological foundation. Perhaps your question will become the topic of one of our future lessons. So leave your suggestions in the comments. Your idea could become the inspiration for our next major analysis. Thank you for helping us build the Eterna system together. Understanding nature today. Building better beekeeping for tomorrow.